All right, welcome back. We're looking at the patterns day 2, IM1. So we're getting into arithmetic sequences. So the warm-up here starts with a sequence of 9, 7, 5, and 3. And we ask, what do you notice about this sequence? So it depends. Answers vary here. And I think in class what we talked about here was the sequence is decreasing, some said. And you could go even further and say the sequence is decreasing by 2, which means it has a common difference of 2. Okay, that's a key vocabulary term that we are going to be using from this point forward, the common difference. So it has a common difference of 2, and I'm realizing I made a mistake. It's actually negative 2 because you were subtracting 2. So it has a common difference of negative 2. How is this sequence different from the one we talked about yesterday? The one we talked about yesterday was actually 3, 5, 7, 9. So how is it different from the one we talked about yesterday? Today's was decreasing, whereas yesterday's was increasing. Okay, so yesterday's had a common difference of positive 2. Okay, yesterday's. What would the next 3 numbers in the sequence be? So if we apply that common difference, we're going to have 9, 7, 5, 3. And if we keep on subtracting 2, that's going to give us 1. And then we're going to cross over into the negatives. It's a -1 and then -3. And so on. The dots mean that this is an infinite sequence, which means that this sequence goes on. The dots tell you that, well, it doesn't end. It actually keeps on subtracting 2 continuously, continuing actually forever. So it keeps on going on and on and on. Okay, so learning goals and vocabulary, those are there for you to read through. So what we did today here is we looked at each of these patterns. Now, if you're working your way through this, you'd want to pause and give these guys a try here. You'd want to take a close look at what's happening here between each of these patterns. For part A, it appears that we are subtracting 2 every time as we move from one term to the next. So if we continue this pattern, we're adding 2. Struggling with my addition and subtraction today. If you continue that pattern, it's going to be 4, 6, and 8. So it looks like we used some addition here. Okay, this next one, it appears that we are multiplying to get from one term to the next. Okay, so we are multiplying by 3 and so on. And if we continue that, well, you can use a calculator there to keep on multiplying through. Each one of those products are going to be negative, but you just keep on multiplying by 3. So in this case, we were multiplying. Okay, now down here, 2, 5, 10, 17. This one's a little bit different. But what we realized in class here was that it looks like we're adding 3, but then we add 5. So this is not a common difference, right? Because it's adding a different number each time. But the difference of the differences, this is what's called a second common difference. You'll look at that a little bit more in IM2, is consistent. So there is a common difference there. So if we continue that pattern, we'd add 9, add 11, add 13. So we're adding 2 more each time. So again, if we look at the second common difference, we're just adding 2 more each time onto the first difference. Okay, so if you add 9, that's going to be a 26, and then it looks like a 37, and then a 50. Okay, so that one's kind of weird. It's not addition or multiplication if we're talking about the first difference. At least it's not consistent, right? So let's keep on pushing forward here. This one's hard to see if you're looking at it in fraction form. So we had the idea in class today to, hey, let's just try rewriting this thing as decimals. So 4 and then 7 divided by 4 written as a decimal would be 1 point. Let's see, it would be 75, right? 1.75. And then -1/2 as a decimal would be 0.5. And then -11/4 would be -2.75. Okay. So if we look at it like this, you can actually see that this actually does have a common difference. we realize that we are subtracting by minus 2.25 each time. And it's consistent. You just keep on subtracting the same number each time, minus 2.25, minus 2.25, minus 2.25. And if you continue that pattern, you would get these last three terms here. But this one here, and again, it's a little bit easier to see if you convert it to decimals. This is subtraction happening, right? Okay, this is subtraction. For E, kind of funky, but right off the bat, you see 1, 2, 3, 4, 5. Okay, well, this must be 6, 7, 8, right? If we just kind of follow the pattern, it looks like it's alternating positive, negative, positive, negative, positive, negative, positive, negative. So this one is not necessarily multiplication or addition or subtraction, but we at least can tell that this thing is alternating signs and it's going up by 1 every time. Now, lastly, the temptation is to say, hey, well, it looks like you're moving the decimal place once to the left every time. And you're not wrong, but if we're talking about the operation here, when you're moving the decimal place once to the left each time, then what you're actually doing is you're dividing by 10. So this right here is division. Okay, so we're dividing by 10. And you can keep subsequently dividing these things to get the next terms by 10. So this one here is division. So if we now back out and look at the directions, back up here at the top, it says describe the pattern, which we did, determine the unknown terms in each sequence, which we've done, sort the sequences into groups. So we have not done that yet. Now, what we were hoping was that you would notice, well, it looks like A and D go together because they both have a common difference. And again, a common difference is when you add or subtract a constant to get to the next terms. Okay, so that would mean, well, if A and D go together, what about B and F, or what about B and F? B and F go together because they both have a common. Well, we're going to leave that blank right there. We're going to make you wait until tomorrow's lesson. But that actually has something called a common. You're going to have to wait. It's not a common difference, though. And a common fill in the blank, you can go find it if you want to, is when you multiply or divide by a constant to get to the next terms. And then lastly, we got A, B. It must be C, and C and E are neither. Okay, so they're kind of their own little thing going on there. All right, so now when we move down to number 2, which of the sequences from example 1 were arithmetic sequences? Well, if you look up the definition of arithmetic sequences have what is called a common difference. Okay, and again, a common difference is when you add or subtract a constant to get from one term to the next. So the sequences from example 1 that are arithmetic are A and D. Okay, don't make it any harder than it has to be. That just simply means that when you're adding or subtracting to get from one term to the next, that makes it an arithmetic sequence because that is your common difference. Lastly here, you're going to have to develop a formula. Okay, so you're going to have to go and do a little dig in on Google here to go and find what's called the explicit arithmetic formula. So if you're listening to this for the first time, I would pause this and go and look for it. But hopefully you find something that looks like this. A sub n is equal to a sub 1 plus the difference n minus 1 times, okay? Where a sub 1 is your first term, okay? First term, which is also known as your initial value, and d is your common difference, okay? So if we're talking about this sequence here that has an initial value of 4, okay, or a first term of 4, and a common difference of 5, and we want to find the first 5 terms. How would we do that? Well, we're just going to keep on skipping forward by adding 5. So our common difference here is 5, okay? So now our subsequent terms here, once we add 5 each time, are going to be 9, 14, 19, and 24. That's going to be our first 5 terms here. So now, if we take this particular sequence here and we apply it to what's called the explicit arithmetic formula, we're going to have a sub n is equal to, well, what's your first term? It is 4. Your first term is 4. Plus, what's your common difference? Your common difference is 5. How many times are we going to add it to get to the term that we want? N minus 1 times. Now, why is it n minus 1 times? A little tricky, but this is the first term, this is the second term, the third term, the fourth term, and the fifth term. So if we want to find the fifth term, how many times are we going to add 5? Well, we're going to add it 5 minus 1 times. Well, 5 minus 1 is 4. So how many times are we going to add 5? 4 times. Once, twice, 3 times, and 4 times. So if we want to get to the fifth term, we're going to add 5. 5 minus 1 times, or 4. Okay, so this right here would be the rule for the sequence, and you can use that rule to predict future values, such as the 100th term. And if you wanted to find the 100th term, you would just do a sub 100, for example, and you would just plug in 100 for n, and then you would just plug and chug, do a little PEMDAS, narrow that baby down, and solve for the 100th term. Okay, at this point, go ahead and give that self-assessment a try. Make sure you watch the video corrections. And once you've done so and graded yourself, go give that portfolio a try. Good job.